It is my pleasure to introduce Professor Scott Stevens on his topic of forest fires in California's new climate reality. There is hope. Professor Stevens and his wife received their bachelor's degrees here at Sac State. Oh, okay. They received their bachelor's degrees here at Sac State, and then he went to Berkeley and received a PhD in Wildland Resource Science University at the University of Berkeley. He has had many honors and awards. He's been a Fulbright Fellowship at 2015 to Western Australia. He's a certified senior fire ecologist from the Association of Fire Ecology. He received the Environmental Science Policy Management Teaching Award. So I do have to tell you this, and I've told this to several people. I wanted to have a forum on wildfires because we have them every year. And so I was looking at all the climatologists that I could find across in this area, and none of them were able to talk about wildfires. But then somebody sent me an article, and sure enough, Professor Stevens' name was in there. So I jumped right away. I invited him, and the next morning I got an email saying, yes, he would be glad to do it. Please join me in welcoming Professor Scott Stevens.
Thank you. There you go. Well, it's really a thrill to be here, to be honest. You know, I'm an alumnus of Sac State. 1985, I got a master's degree here also in 88. My wife Mary's right there, dead center in the brown. She also got her MU degree in 86. So in some ways, this is like home week a little bit, which is kind of cool. In fact, when I started teaching at Sac State as a grad student, I did labs for a while, and there were professors that were so important to me: Becker, Symes, Oldenburg, Vreelander. There was all these folks from many years ago. But I remember my first lecture assignment in my whole career was EEE-9. EEE-9 was like Introduction to Digital Systems or something. And I taught it in the old anthropology building, which right on this spot. So the old anthropology building used to do something. Okay. Check here. Go ahead. The old anthropology building was a little one-story job. And I remember it was my first lecture in my entire life. And I taught that class a couple times. And it's so interesting. I bet you we're within 100 feet of that piece of ground, even though this is a new building. So there's a lot of really interesting things going on here coming back to Sac State. And as you said, we're going to talk about fire today. I'll get through this presentation, then I'm hoping that she'll give me some really nice questions. That's what we're after, is questions. So interesting, I got a double E degree here, worked in engineering for a while, but then, as you can imagine, I shifted more in the natural sciences, forestry, fire. Berkeley, I was a professor at Cal Poly San Luis Obispo, fellow CSU campus, of course, for a while, and then came back to Berkeley in 2000. So I've been there now almost 24 years, which is crazy. So you think about fire in California, and it's impacted so many of us. My best friend lost his house. I bet you there's folks in the room that actually maybe even lost their own property, or friends that lost property. We get smoked out all the time. Insurance is going crazy. We're getting it always is getting, eliminated. Costs are going up. It's done things that are basically almost touched everybody, and of course, fire has had big impact in California for a long time, but it's gotten bigger impact. So I want to talk today a little about just what can we do about it. Okay. First context is the idea of a little history. So here's an old little picture, 1915, the Northern Plumas National Forest. So that's a little guard station actually built by Walter Robertson, who actually was a forest guard, early Forest Service employee. So you look at that nice open forest condition, and here's some quotes from some of the preeminent forest researchers in the early 20th century. Shown Kotak. California pine forests represent broken, patchy understock stands worn down by the attrition of repeat light fires. Extensive crown fires are almost unknown in the California pine region. Crown fire is when fire burns in the canopy, right? So those are the fires that have the highest intensity, the highest damage, most difficult to stop, and also the ones that are also the most damaging. And here we are in 1924, and the preeminent researchers are saying that they're almost basically unknown. So a lot has changed in 100 years, and we'll talk about that. So you take fire out of these systems for a long time, both indigenous burning and lightning fire. What are we going to have happen? This is a picture just outside Yosemite. So this is when you go Highway 120 and you're going into the park, and you drive up that beautiful road. Of course, in 2013, the rim fire burned there. That was almost 10, 12 years ago now. So it just turned out we actually found data that was actually collected from the rim fire area from 1911, 6 years after the Forest Service was created in 1905. So by chance, I was out working with a crew of undergraduates, and here we are, I'm taking some pictures of one of the plots that actually you see the date there, July 2013. So you got a tape on the ground. We're actually remeasuring the same area that was measured in 1911. And then lo and behold, rim fire happened. So there's that big log you just saw in the previous picture. It's a big sugar pine log. And this is high severity crown fire. So the fire burned through this site, killed all the trees, really did severe damage to the ecosystem. And then when we go forward a few years, this is 25 September 2013, here we are about 3 years later. So you can see, we see shrubs coming back, we see grasses coming back. We don't really see conifer trees. Can I do something? Conifer trees coming back. So we really have a challenging environment where we do have native plants coming back, shrubs and grasses, because their seeds survive that fire. But the trees, you've seen conifer trees in California, generally takes 2 years for a cone to mature. Once the cone matures, it opens. Seeds are dispersed out, wind dispersal, also small mammals. So there's no closed cones here, like you see in maybe Yellowstone National Park, where we have closed cones, fire burns, the cone opens, we call that serotiny, and then the seeds come out. Seeds survive. Here, the seeds open up, and exposure to that type of temperature kills them. So unfortunately, when we have low areas that burn like this, we find out, actually, I'm going to change this mic. There we go. When we have large scale areas burn like this, we take the seed source of the conifer trees out because it doesn't survive that type of temperature exposure. So that's why if you walk around here, you'll see a conifer tree or two, ponderosa pine, sugar pine, Douglas fir, but you won't see extensive regeneration because the seed bank has been really killed by the fire itself. That's the type of problematic fire we have in California because we're taking forests and we're type converting to things like shrubs and grass. It's not to say shrubs and grass aren't important, but when we have things like the rim fire, we have areas 20,000 acres, 30,000 acres continuous that have all been burned like this. And unless you do reforestation, it's not going to come back to a forest maybe for 100 years plus. So let's take a second, just look at some data. So here we have data from 1911, that data I told you, that literally is that plot we were just in. So we have data from that plot in 1911. In 1911, there were about 20 trees per acre measured that were 6 inches in diameter or larger. Take a look what we measured in 2013, 224. That's a real giant increase. If you actually look at the average over the whole big area, it's about a 4 times increase. So that's about a 10 times increase. But what that means is you take fire out of the system by suppressing it and actually reducing indigenous burning, you basically take a factor out that thins the forest, keeps tree density down, regenerates, recycles nutrients. So we have this incredible change in forests that I think we don't really perceive very well. The picture on the left here is one of my favorite places in the world. It's in northern Mexico. It's the Sierra San Pedro Martir. The Sierra San Pedro Martir is about a 6-hour drive south of San Diego. And it's Jeffrey Pine mixed conifer forest. So the neat thing about this place is they didn't start putting fires out until 1970 because they had no road there and actually has no fire. It's never been cut. So that picture of that forest right there is analogous to what California forest used to be. That forest has got around 20, 40 trees per acre, about the same size as with the 1911 data. And you can go down, it's a national park. You can go down there today and camp. In fact, we're going there later this month for another research trip. So the data that we have in 1911 literally almost describes to a T what you can go down and see today in the Sierra San Pedro Martir, where fire suppression didn't happen until 1970 and no cutting happened. So it's that really interesting of a place. And the picture on the right is actually the same place I showed you before it burned, that density of forest. I got to show you one slide with data because I think this is really important. So we all know competition, plant competition. If we grow a garden at home, right now we got some carrots and some radishes growing in my backyard. Those seeds come up. There's so many of them next to each other. You got to thin them. If you don't thin those seeds, you don't thin those plants, and basically nothing grows, right? Same thing happens to trees. If you have too many trees per acre density, basically you stagnate growth and you cause more problems because of competition. So this diagram basically tells us about that. What we have on the left is a competition index. It's a competitive index of trees. We call it relative stand density index, okay? And we have two plots of data, 1911, which is on the left, and 2011. So the 1911 data is the data I just told you about we found from the archives, okay? And then the 2011 data is actually Forest Service data. So it's more current data from the same place. We're talking about mixed conifer forests in the Sierra Nevada. So the competition is broken up into 4 ranges. So it goes from 0 to 100%. 100% literally means you got as much biomass on that ground that's actually ecologically possible, maximum. And then everything below that is a proportion. So previous work in this area says if you have between 0 and 25% of maximum biomass on your forest, you're actually in an area we call free competition. The trees that are there under that regime are so low density, they almost don't compete with one another. They're separated, there's good soil, there's good water. So those trees are essentially in very low competition. From 25% to 35% of maximum, that's partial competition. So you're starting to get a few more trees, right? You're starting to get a few more trees per acre, 25 to 35% of maximum. And then when trees are starting to compete. And then from 35% to 60%, you see over there's full occupancy. That turns out to be where most foresters in California like to operate. They want enough trees on the ground to grow trees as fast as they can to harvest. So they generally stay between about 35 and 60%. If you go too high, the competition's so severe, the ecosystem can basically have really a catastrophe just through mortality. So that's why we say from 60% up to 100% is imminent mortality zone. You got so many trees per acre. They're competing so severely. You put a drought on there, you put on bark beetles, you put some disturbance, and just literally the competition could cause the trees to die. That's exactly what happened in 2012 to 2015 in the Southern Sierra Nevada. Remember that when we had the drought, 2012, 2015? Estimate is 160 million trees died. 160 million trees died. Not a single fire. It was purely competition. Now take a look at the 1911 data. The data basically, the wider the violin plot, more trees. So in 1911, most of the areas are in what? They're in the free competition and partial competition zone. They're basically in that zone where they can actually deal with things like drought. They can deal with things like bark beetle attack because they're in that zone of partial competition or very low competition, right? Take a look at 2011. It's almost inverted, isn't it? Most of our forests are actually in the imminent mortality or full site occupancy. That in a nutshell tells us how departed our forests are. And this data comes over 100,000 acres. This isn't 10 acres, this isn't 20 acres. We're talking big area, okay? And I think this is analogous to most forests in California, mixed conifer. Ponderosa pine, Jeffrey pine, sugar pine, Douglas fir, white fir, incense cedar. When we take fire out, we harvest the largest trees. We allow those trees to regenerate. They grow, grow, grow. They get to a point where they're competing so severely, we put a 4-year drought on them, and you can kill 160 million. And that, in a nutshell, really is the way our forests are in California today. That Sierra San Pedro Martir forest I showed you that picture of had the same severe drought. 1 tree per acre died. 1 tree per acre died. And then it burned in a wildfire. 80% lived. So think about that. It went through a severe drought for 4 years. Then it burns in a wildfire, and 80% of the trees live. That's exactly the way forests in California used to operate. Today, we have that. So even a 4-year drought will kill 160 million trees, and climate change makes it worse because it puts more stress on those trees in terms of evapotranspiration, the ability to get water. So that's why I wanted to show you that diagram. It comes from a paper that we all worked on together. So what are we going to do about it? Okay, now we're going to get into some things that hopefully are a little bit more operational and give us hope. So forest restoration treatments. So if you got a forest that had at one time 30, 40, 50 trees per acre, today you got 400 per acre. You have a forest that in the past had maybe 10 tons of fuel in the ground per acre. Today we have easily 30, 40, 50 because we've taken fire out, fuels are accumulating. So what are we going to do with a forest like that? So we're going to do a restoration. The first thing I want to show you is what tools do we have in our toolbox? We really have two types of tools. Fire is a tool like prescribed burning. We also have mechanical methods like thinning. Those are our two tools that we have in our toolbox, right? So I'm going to show you a sequence of slides from a 20-year project that we have actually right up here off of Highway 50. It's at Georgetown. Georgetown, there's a forest up there called Blodgett. It's what our research forest at UC Berkeley. Anybody can use it, but I've been doing research there for about 25 years or so. So we started a project just over 20 years ago about doing forest restoration with different techniques and trying to measure the impacts or effects. And this idea of restoration thinning, I just want to comment for a moment. Sometimes when I talk about this, people think, oh, that's just a timber grab. You're just trying to make some timber company money or something like that. And I'm not saying that's wrong. I mean, there are timber companies in the States. Here, Pacific Industries is the #1 largest landowner in the state of California, and they're the largest timber owner and also a large timber operation. But if you're going to do restoration focused work, what you do is you actually focus on what do you want to leave. So you go into the forest. Let's say we're in a forest right now. We kind of look around. We see what species of trees are here. What sizes are they? What pattern are they in? And then we think about what we want to leave to actually think that we can actually enhance resiliency to the future. Things like drought, things like fire, things like bark beetle attack, climate change. So we figure out what we want to have. And then anything in excess of that, we take. So that's what restoration thinning is. And that's exactly what I'm going to show you pictures of. It really has this restoration focus, but it can generate lumber as well. But it's not going to be a timber grab. I'm going to show you pictures of both mechanical only restoration and fire only restoration. We also have a sequence of mechanical thinning followed by fire. So the combo. I'm not going to show you that one today just because of time, but I'm going to show you this sequence here. This is just a plots, different colors or different treatments. The red ones are fire only. Each of them is about 40 to 60 acres in size. So they're about 60 acres. They're not huge, but they're replicated 3 times. The experiment was initiated about 2001. And this is the place that we continue to work on and get information. Here's the beginning. So you see this is 2001. Mixed conifer stand, just like the one I showed you before. Ponderosa pine, white fir, incense cedar, California black oak, sugar pine, one of the more common forest types in California. Hasn't burned since about 1898. We know that from tree ring studies. We actually did a fire history here on tree ring studies. Before 1898, this site used to burn every 7 to 15 years. And that we have data back to 1650 on that. So the trees are just telling us, the trees and the stumps, so we have papers published on that. You can see from about 1650 to about 1898, a fire every 7 to 10, 15 years, and then it just ends. It's almost like someone took an eraser. And the ends because fire suppression, because we start put fires out and we're very good at it. We continue to be very good at it, okay? I want you to watch that tree in the right-hand corner with the arrow. That's a California black oak. So that oak is going to be your focal point as we go through these pictures, right? So this has got about 400 trees per acre. It has around 30 tons of fuel per acre. That's the deadened down limbs that we see here. 30 tons, can you imagine? That means if you get a tractor and actually just go around and scrape the ground and pick up the wood, in 1 acre, you got 30 tons of material on 1 little acre, okay? And then 40 tons of duff. The duff is a decomposing layer just above the soil. It almost looks like a compost. So you put your hand down there, kind of grab it. If you look at it, you can't really see needles. You can't really see morphology because it's decomposed. That's about another 40 tons. 40 tons on the ground. So that's a lot of material, okay? So what are we going to do? We're going to do the restoration treatment. We're going to do mechanical only. So we're going to go forward here. Here's one of the machines. So this is a masticator. Masticator is excavator. The excavator digs big trenches, with a big bucket. But instead of having a bucket on the end, you have a cutting tool that spins around 500 RPM and it's got teeth on the bottom, metal teeth. It chews up trees in place. We wish we could use material that are submerchantable. But submerchantable in California is about anything 10 inches in diameter or less. So below 10 inches in diameter, you really can't sell that tree to a sawmill. People are working like crazy to try to figure out what to do with that material for an economic gain or even break even. Biofuel, biochar, all sorts of cogeneration of electricity. Use it to actually go to a boiler, generate electricity. A lot of ways to think about that. And it turns out none of them are economic right now. There's a lot of people working on that. We have people at Berkeley working on that. It's a really important area. Here in early 2000s, we had no place to send this material. So instead of taking it and actually moving it to a site for use, we actually shred it in place. So the masticator does that. So we go through and we take the trees above 10 inches diameter, we harvest them, take them to a sawmill, and then we leave the tops of the trees and the limbs. And then after that, the trees that are too small, we masticate. Masticator simply comes up to a tree and actually just drops that boom on top of it and shreds it in place. Gone. Okay. That thing does 2 acres a day, costs you about $600 an acre. So that is a lot of money. Okay. $600 an acre, about 2 acres a day. That's one full-time operator. Makes sense to do around maybe homes, urban interface areas. Hard to think about doing that over vast areas of wildland because it's so expensive. Okay. But it is something you can use to try to reduce your density of trees. So let's take a look what happens after the first treatment. So there's that black oak up there in the right-hand corner, right? Still there. And yeah, not surprising, we reduced forest density because that's exactly what we wanted. But you can also see an awful lot of material on the ground. So 100 years of suppression already had a high fuel load, and then we add to it more from that mastication. If you model this from a fire behavior standpoint, it's a wash. Essentially, you have less crown fire potential because there's less trees to actually propagate the crown fire, but there's enough surface fire or fuel in the ground that the flames just from the surface are large enough to actually kill the entire stand anyway. So it's a different type of kill. It's not burning, it's actually heating. So let's go forward now a couple of years. So that's 2003. Here we are, 2010. And we start to see regeneration coming in the understory. We all know that forests are alive, right? They're basically regenerating and we're seeing regeneration happen. So, but interestingly, at this point, 8 years later, 75% of the masticated fuel bed decomposed. It decomposed by native fungi. So that fuel bed had been incredibly reduced. And by now, the fire behavior in this stand is incredibly low. So the trees would survive wildfire. So it just took about 6, 7, 8 years before that thing actually decomposed that surface fuel layer enough sufficiently that actually got to a point. And here we are in 2010. Let's take a look a few more years, 2015. So now we're out 13 years and we start to see, yeah, the trees are getting larger, aren't they? The understory trees, just like what happened before. So we see that cycle. What do? We actually treat it again. So this is actually after 2 restoration thinnings. And this is kind of what it looks like today. And it's really a marvelous condition. Fire behavior potential here now from wildfire is moderate. Probably 75 or 80% of the trees in the overstory would survive a wildfire. And it turns out it's sequestering carbon from the atmosphere at the highest rate. Trees are growing fast because we thin the stands. We're putting wood on these trees. And then we actually harvested it a second time from a restoration standpoint, and we made money both times. So it's not as if we're a timber grab, but we are doing this in a way that actually provides capital maybe to do other work. And not everybody's going to be able to do this. Some forests don't have legacy of some larger trees left because they've been cut over too much. Others do. There's a lot of places in California, I think you could do this work and at least break even. You could break even with the costs. You wouldn't have to subsidize it as much as maybe sometimes we think we have to. Let's go another one. Now we're going fire only. So same forest condition. This is only about a half a mile away from that other place I just showed you. That's a big old sugar pine dead center. Same trees per acre, same amount of fuel per acre. Hasn't burned since 1898. But instead of using a machine this time, we use fire. So this is a prescribed fire. This is something that I've learned over the years to work with. I've been on about 140 of these now, roughly. So you can see we're burning at night. Makes sense because relative humidity is as high as possible. Temperatures are as low as possible. And you can see even the understory is torching. There's so many trees here, we're getting flaming combustion in the understory. But we actually have the weather working for us. And these fires went off very, very well. Right now, as we think about the future, if we want to begin to do this at larger scales, and we actually have policy that says so, we don't really have a workforce in place to do this. We don't have enough people trained in this area to really do what Governor Newsom and Biden and his administration are asking local communities to. People want to get more and more prescribed fire on the ground. And it's certainly not without risk, but it also can be reasonably managed. So that's what it looks like from the fire that we put on the ground. And just take a look now, what happened? Well, there's that big old tree. Turns out we killed 75% of the trees that were below 10 inches. So the prescribed fire did a pretty good job. We're going after those trees that were small, right? But of course they didn't leave, did they? You don't really burn those big old trees. You only burn the foliage, the small stems. So the trees are basically still there. So let's go forward a few years. So that's 2003. Here we are, 2009. Shrubs coming back. That's a native shrub that actually grows, Ceanothus. We start to see some of that mortality starting to come down, getting knocked over by snow, getting over by rain, fungi's getting in there, knocking it down. So what do? We burn it again. So here's a second fire into that site. I remember being here and I just said, oh my goodness, I'm right at that tree. I'm going to take a picture. So I took that picture. And what happens after the second fire? Wow. I have a really good colleague, friend of mine, Rob York at Berkeley. He has a couple rules of thumb. He says, one rule of thumb is if you're standing in a forest and if you can look up and down that grade and you can maybe see a change in topography, a small stream going up the other side, and there's a small stream going right there. You can see far enough down that forest that you can see the change in topography. A little small stream says you're getting there. You know, you're starting to get that density of the forest down that you can actually make a difference. That first picture, you couldn't see 40 feet. You know, you couldn't see 40 feet. So here we are after second fire. Let's go forward some more. There's actually 8 years after the second fire. Same tree, the sugar pine's doing great. Some of these trees are continuing to fall. We get a few more shrubs. What do? We burn it again. So this is the third fire in 2017. And then this is kind of what it looked like in 2018. A few more trees die, a few more shrubs. And this is pretty much what it looks like today. So a couple of things about this is it was very effective. It took minimum of 2 fires to do the work, minimum of 2. And the thing about this, like in any of these options, the treatments never end. If we just stop, we go back to that same initial condition. And this is something that's really hard. When you talk to indigenous communities in California, they talk about active stewardship of their land for millennia. They talk about, you know, doing stewardship primarily by fire, other techniques as well. But they talk about this as actually a relationship with the land and actually commanded by Creator. I know about 4 or 5 tribes I'm working with right now, and they all say things a little bit different, certainly, but they talk about this connection to land. Creator tells us to steward land. We need to do this forever. This is exactly what we have to do. We have to steward our lands to actually allow them to get in more conditions like this. So when the wildfire comes, we have flame length 4 feet. When the wildfire comes, most trees survive. When the wildfire comes, maybe suppression can be used to actually keep the houses from burning down, and our fire insurance is still okay. So that's the kind of things that really would take to kind of move this thing forward. And we have the tools, I think, to do it. I'm not going to talk about that. We want to make sure we have plenty of time. I've told you all about that anyway. I want to show you one thing about, remember I showed you that relative stand density index figure before, 1911, 2011? Now this is actually evaluating our treatments at Blodgett. So the control, the pretty much the same, isn't it? Most of it's imminent mortality or full site occupancy. That's the initial condition. But you take a look at our treatments, we aren't actually down as low as the 1911 data. Remember the 1911 data was primarily free competition and partial competition. And we see most of us, we're in kind of full site occupancy, and maybe the mechanical plus fire treatment, the one I didn't show you, is getting closer to the 1911 place. So that tells us that as climate changes, warms, fires happen, at least in this evaluation, that the mechanical plus fire treatment has probably the best potential to keep those trees healthy into the future. And it probably tells me that if we do a mechanical treatment again, we need to thin down even further. We need to thin further to get down a little bit lower to that lower competition zone. So that's really just an evaluation of how we did. That data or that technique of evaluating resilience didn't exist in the early 2000s. If it had, I think we would have used it. We would have used it to try to come up with our treatment a little differently. Let's go to Yosemite. So Yosemite, instead of doing mechanical treatments, we use managed wildfire. So there's places in Yosemite that have been managing wildfire in the wilderness since 1972. One of them's Illilouette Creek Basin. There it is right there. There's Yosemite Valley. That's right behind Half Dome. So if you're standing in the valley and you see Half Dome, look behind it, that's Illilouette Creek Basin. There's a bunch of fires that have burned there over the years. We'll take a little bit more of a look at that in a moment. Here's a picture from one of those fires, the 2001 Hoover fire. Higher elevation. We're in true fir forest. We're in red fir, white fir, Jeffrey pine, lodgepole pine, quaking aspen. A little higher up in the mountain, okay? So here's a place that's burned a couple times, and we created a high severity patch. High severity patch is simply an area that trees got killed. But take a look, trees are regenerating. You're close enough to live tree sources that the seeds are coming in from adjacent areas. A lot of times when I take people in here, if you go to the Mono Meadows trailhead on the road to Glacier Point, if you go to the Mono Meadows trailhead and go down Mono Meadow Trail, 2 hours you're in here. It's pretty easy to get to. A lot of people feel this is too messy. Got too many dead trees, logs on the ground. Looks a little bit messy. Not trees everywhere. But this is actually the most sustainable forest I know in California in terms of its ability to deal. Here are actually pictures of fire perimeters in Illilouette since 1972. And the numbers actually are how many years previously did that area burn before the current fire? So that little enclave burned 5 years before the white fire surrounded it. Up here, the one that's hashed, 7 years earlier, that one above burned. These are self-limiting. There is no fire suppression here at all. All we're seeing is fires are encountering other places that burned previously, and in some instances are going out alone. And the reason is the fuels are so low. It takes time for fuels to accumulate. So we call those limited fires. And over here on the right side is what happens when you get more years, 23 years, 30 years, 13 years. We're seeing fires burn right over the top. So the fires are going right over the top with no fire suppression. So this is really interesting. It tells us that there is some self-limiting behavior of these fires. And you do some statistics on this. Brandon Collins, one of my colleagues, the first one, the thing on the right is a way that we do some statistical analysis called a categorical tree. All it does is try to separate data into like groups. So when Brandon did that, 9 years popped out. So what that tells us is if a fire burned 9 years, 8 years, 7 years, 6 years, 4 years previously, and another fire hits it, in 90% of the case, it goes out on its own. It's limited. I think this is the way California forests used to operate, period. It was so much fire on the ground that it actually had so many areas burned that the next fire would encounter a place that previously burned just a few years earlier. There wasn't enough fuel, and it simply went out. So this is really remarkable in terms of about 10 years or so. So it tells you if you have places that have burned, at least under these kind of conditions and severity, that about 10 years or so, you're going to have this buffering capacity. One thing about this that's so important and so difficult, I remember we showed this to the Yosemite superintendent. And the thing that actually was, they go, oh my goodness, it never ends. All it says is, what have you done lately? Has the place burned or so in the last 10 years? I thought maybe if you had 4 fires over the last 40 years, maybe you bank a little fire bank. You know, it burned 4 times in 40 years. Hey, maybe I can wait for 30 years and be in good shape. Statistics are really clear. That is not the case. All that really says is, what have you done for me lately? Have you burned in the last 10 years or so? And if you have, we have self-limiting behavior. If you don't, we actually don't. I think indigenous people did this routinely, burning small patches of ground for a lot of reasons. Food, medicine, ceremony. And the mosaic created by all that burning created self-limiting landscapes and fire spread. And then we inherited those, and then we took fire out, and then you saw the conditions, and then we get these fires that are basically just unbelievably intense. So that's kind of the thing we got to work against. But here at Yosemite, we found that, hey, it's working. I got to show you something about water. I'm going to get out of here. Picture on the left is 1970, before the fires came back in. Picture on the right is actually after fires have been in there about 50 years. 22% of the forested area is gone. 22% of that area has changed to grassland, wetland, or shrubs. So it's gone really from a wall-to-wall tree enterprise, and National Park Service is just as good putting fires out as the Forest Service. And in 1972, they basically decided to let fire back in. 50 years later, we get a mosaic of many more vegetation types and really break up that continuity. But 22% of the forest is gone, and the wetlands have been increased. And it turns out people have actually done some really nice work on this. And it turns out the water has increased from Illilouette Creek. You look at the water coming out per unit water in as stream water, it's significantly increased in Illick Creek since 1972 when that fire thing went back in. And the places that are pink that are outside the park, all of those have not burned, and every one of those significant decrease in water out. So there's a real interest connection to water here. You know, the ability to maybe sustain water supplies we all need. I got to tell you about it. One more thing. Stewardship Project is a policy project that I'm working on with Don Hankins, who's actually Chico State professor and indigenous, Sarah Clark, an attorney. And we basically look at this list of initiatives from the feds, and we find out that the initiatives from forest fire reform since 2000 or so, a lot of initiatives, a lot of try, and we're not getting any better. We are not getting any better. That is a pure fact. You all know that. Things are getting worse. So what about something new? The idea we've come up with is indigenous stewardship up front. The idea of learning from indigenous communities, thinking about how they actually manage land through oral history and also continuation of their act practices. Can we actually partner with them? So the Stewardship Project's a 50-50 partnership between indigenous communities and Western science. And we've been working together about 2.5 years now. And we've come up with some policy recommendations in these 4 categories: the tribal right to steward land, workforce and capacity, regulatory reform, and then the ability to have kind of more variability or more ability to manage public lands with creativity. So we've worked in this now, and it's really been exciting. You know, when I love talking about fire and forest. I teach a class at Berkeley where we have indigenous leaders come in and talk. I tell you, when those folks come in, it changes everything. You know, it just changes the whole tone. When you hear a person that talks about their history and their history of land stewardship through their generations, 1,000 years, and they talk about what they want to create, their philosophy, the idea of actually them in the land, it really gets to people in ways that, frankly, I don't. So I think it's just a powerful way to communicate, especially to folks in urban areas and also environmental groups. I think it does both those better than I. So the current status is we're working on academic papers in this. We got a group that's helping us with connections to DC. Just Tuesday of this week, we spent an hour talking to the U.S. House of Representatives Natural Resources Committee, Republicans and the Democrats, to talk about changing policy, to talk about some of the things we just talked about here, indigenous stewardship, fire treatments. So we're actually talking to the U.S. Senate and House staff every week about this. And I'm hopeful. So I'm hopeful that we might be able to have a little bit of a change in Congress. We know Congress is broken a little bit, but but if, you know, I've talked to both sides. You know, I had a great conversation. There's a woman senator from Wyoming. I forgot her name, forgive me, but she is actually the caucus leader of the Senate Western Republicans. So she actually is the leader of all Senate Republicans in a caucus of how they work together. We talked to her for an hour and a half. She is really excited about it. So it feels like in some ways this might be an opportunity to actually think of how we might change our federal policy to embrace more stewardship, ideas of landed people, and have indigenous ideas maybe up front. That's what I'm hopeful for. And here's the very end. A lot of things going on. There's a lot of possibilities too. You know, this idea of using mechanical treatments, prescribed burning, indigenous stewardship, managed wildfire and remote areas. California's put a bunch of bucks into this ever since the last 2 years of the Brown administration into a Newsom administration, $2.6 billion. Anybody can go for this money. It's CAL FIRE grants, small community, workforce, nonprofit. You can actually go for one of these grants to help your community. They come up every year for CAL FIRE, minimum $400 million. So, and then the feds have put a bunch of money on the table through the several acts, Work Better Act, you know, infrastructure, over 2 billion, 2.6 billion, or whatever I got written up here, some giant number. I'm afraid still that the feds have a lot of money and not the capacity to move. And I actually know now the GAO, the General Accounting Office, has been asked for a review of the Forest Service, thinking that they're not meeting their goals. And this is not totally surprising because we don't have the workforce to do that stuff that we've chatted about. And as you know, Congress isn't very patient. If you put, you know, $2 billion on the table, they want some results. And one of the things that worries me is if we don't get results with this nice giant funding enterprise, are you ever going to getting money again? You know, I think it really is difficult. The CAL FIRE grants are doing better. The CAL FIRE grants are getting stuff on the ground. Maybe some of you are actually part of that. So I say there's opportunity. but there's also real worry. I just think about my kids and your grandkids, my kids. What are they going to inherit from us? That's the thing that really drives me nuts. Are we going to hand off a forest in a condition that's so vulnerable to continued climate modification because of increased temperatures, more variability in weather? Are we going to hand that off and say, thank you very much? Or are we actually going to hand off something that actually has more resilience and the capacity to deal with the future? If we don't hand off that latter, our kids and our grandkids and their kids are all going to look back at us, frankly, and say, why didn't they act? Why did they just sit there and do nothing? And that really worries me. I'm saying things are getting better, but I think we got 15 years. If we don't change this trajectory, we're not going to fix it in 15 years, not even close. But if we can actually start to show real significant change in terms of stewarding our lands, getting these systems back into systems that actually can deal with the future, deal with wildfire, deal with climate change. If we can do that, we can hand that off to our next generations and feel pretty good. But if we don't do that, I'm going to feel like my career has been, frankly, a loss. So that's why I've been working in DC, working in Sacramento, and continue to do so. I'm hopeful. The research is clear, it can help. It does work. But the question is, do we have the capacity? So I'll stop there, and thank you very much.
Questions, but I'm going to ask the first question because I have the microphone. Yeah. So what struck me was one of the things you talked about was the fire suppression. Thank you. Fire suppression versus the mechanical. And then you didn't talk about the mixed, but when you were talking about those, I was thinking about the cost related to the different ones and how many people it takes to monitor a fire suppression. And so can you discuss a little bit about costs and the differences on those?
No, that's very good. We have this paper that just came out on the 20-year analysis of that study, and it actually includes economics. So the economics of it is that we actually show that the mechanical only treatment makes money, actually enough money to actually fund the prescribed fire operations. So the cost in roughly a prescribed fire, if you're going to do maybe 40 acres, 50 acres, 100 acres or so, you're probably looking easy, $200, $250 an acre to do that. Through your planning costs, you got to put in fire line, get people out there. If you do a bigger area, 1,000 acres, you're probably going to cut that by at least 50% per acre. But it's always going to cost you a little bit, money in terms of in the bank. And then the mechanical treatments, at least at Blodgett, they're generating, on the order, when we did thinning of those 6 units, they're all about 50 acres or so. So we're talking about 300 acres or so. It generated about $400,000. So, and then when we look at the long term, the mechanical plus fire you alluded to is interesting. Turns out it's a wash, but what we get from revenue actually matches what we need for burning. So that actually is a potential again. It's so interesting in the prescribed fire capital of forest, the United States, interestingly, is the Southeast. The Southeast has been burning like mad forever. Florida burned 1.2 million acres of forest last year. Georgia says they did more. Last year, California did 60,000. 60,000 versus 1.2 million. So in some ways, it tells us certainly different climate of Florida, different topography, whatever, that's all right. But it just shows you when you have a workforce and a culture that actually is in tune with that, it can work. So we have to grow that. And of course, we're going to make mistakes. I've been on fires. We've had escapes. And inevitably, when you start this type of program, you're going to have escapes. I guarantee it. And the question is, do we have the political capital to deal with that? Hopefully no one gets hurt. But inevitably we would make mistakes because think about that. We're starting out with really a fuel loaded forest condition. We don't have a workforce that's got a big training. And we also have really vulnerable politics. So in some ways we're ripe for a problem. Okay. So I think, but still the counter of that is continuing to do what we're doing and it's not working at all. So hopefully I answered it.
I have 2 questions. One's kind of a little silly and the other one is a little more serious. About 5 or 6 years ago, someone recommended when we were having some of our big fires that we should be raking our forests. Is this the equivalent of raking the forest? And my second question is, if you go from 300 trees per acre to 60 trees per acre, how does that affect your carbon dioxide removal?
Well, that's a great question. And I remember the same comment. President Trump said that, and I think, yeah, I know. Yeah, but the idea of that, raking the forest was incorrect, but the idea of actually managing forests to actually reduce the vulnerability is absolutely correct. So the communication wasn't great, but the idea that you could, do treatments like we just saw and actually make a difference is true. I'm afraid he just didn't communicate that very well. But then your second question about the idea of carbon dioxide. So when we look at our forests today, they have more carbon in their wood products, in their wood, on the stump, than they have sustainably could be actually collected to the future. We have more carbon on our forest today than we've ever had. And but the problem is, how stable is it? So we've done some work on that, trying to look at the stability of this carbon out through climate change, out through the future. And it turns out it all depends on the annual probability of wildfire. So what's the probability of wildfires going to burn a place every year? When I started my career in the early 90s, it actually was around, it was less than 1%. It was like 0.4%. You could calculate about 0.4% chance of you having a wildfire in Sierra Nevada. Today, it's close to 2. So from 1990 to 2020, whatever, it's gone up from about 0.5% to 2%. And as that continues to climb, we find essentially very quickly that we start to get to a point where we're losing more carbon than we're actually gaining. I would say the statistics say we're still actually on the left side of that curve. We're still able to deal with more carbon, but it's coming up fast. And so I would say, try to come up with a philosophy or an idea where you have carbon on the forest, still taking in CO2, but also one that has a capacity to do that for 50 or 100 years. I think that's what I would argue, and a lot of people have. But that does mean we have more carbon. We have too much carbon, and a lot of our forest today is going to go down. But then we actually have the capacity to hold that carbon longer. It's a good question.
So if I think about the last huge fires that we had up in Mount Shasta area and south of Dunsmuir, where you can still see all the burnt trees, was that just a great start for us to start managing those forests?
Yeah, that's interesting. So you're thinking about, so we have those severe fires like right off I-5. You can see them when you're driving up I-5. I go up the same way. Drive Yosemite, go up and look at the Dixie fire, that's right off Highway 70, Feather River Canyon. So that is a really important question, because in some ways it really is where we are today. Essentially what you have there is you have so many standing dead trees. Many of them never were removed. You didn't take the lumber to a sawmill. A lot of it's still standing. And then when you have the standing dead trees, it does look really difficult. But actually, when they come down to the ground, when they break in about 10, 15 years, they're actually more hazardous. It's actually very hard to burn up a standing dead tree. Even though it looks like it'll burn like crazy, you put it on the ground, it actually has a higher bulk density. That just means it's much better at heat transfer to the object next to it. So you can get horrendous fire behavior when the trees come down. So when you have the trees come down about 10, 15 years, and the shrubs are growing already, because the shrubs are actually in the soil seed bank and they're all native, but you have shrubs coming up, and then you could have easily 300 tons per acre, easily 300 tons of wood on the ground in a high severity patch, like you said. So in 15 years, it's actually in a condition that is so prone to another high severity fire. And we've now seen at least 3 of these in some places in California: burns high severity again, burns high severity again. So you're almost in this loop. And how do you get out of it? How do you get out of it? Reforestation, you plant trees, you begin to plant them, you deal with the fuels that are there already. If you plant the trees in that place and don't deal with the fuels, you're basically going to just kiss that goodbye. Eventually it's going to burn. So those trees that were there are just going to be dead. But if you do some work, it doesn't have to be the whole landscape. Maybe it's 20% of the landscape, but you go out there, take out some of those trees, burn them, send them to a sawmill, then actually do reforestation. Brandon Collins, I mentioned Brandon, he's actually the head of the ecology program of Forest Service in California now. And they have funding right now to reforest 1.5 million acres in California. 1.5 million, because of high severity patches you just alluded to. And they're trying to create a plan to do that right now. They don't have the seedlings available yet, because that is a massive amount of ground. But I would just say, in some ways, once you get to that point, it gets much more difficult. It's so much easier to work in the green forest, the one that's actually still alive, and do that stuff we chatted about, the thinning, the prescribed burning, manage wildfire remote areas. When you get to that point, your options have been cut by 80% and they're more difficult. How do you get out of that fire severity loop? That is really difficult. That's probably one of the biggest conundrums we got. How do you get out of that thing? Or are we just going to have forests keep converting to things like shrubs and grass? So there are things to be done, but I would just say, let's work on the green forest and get that in a better condition.
There, one comment and one question. Cleveland Forest up Highway 50, they reseeded that, and it's massively, dense now. My question is, you've talked about wildfires. What about wildlife? Is there any correlation with clearing the forest and the amount of biodiversity?
There sure is. And this is an important piece, and there's no doubt that the wildlife are always going to basically the way they deal with a forest is structure. So just like you alluded to, is it maybe a dense forest? Is it a very open area because of maybe high severity fire, a dense open area because of clear cutting? And all that is going to be really just what animals and habitat are going to be alluded to. And there's some really good research on some of the more important species, not the more important at all. It's actually the endangered species or some of our species of concern. California spotted owl. The California spotted owl is kind of the most, in terms of a species in the Sierra Nevada, the one that's looked at the most. It's actually, numbers are declining. People are worried about it. There's actually research that shows Gavin Jones is probably the eminent California spotted owl biologist. And he shows that if you do the treatments we looked at here, these kind of prescribed burns, restoration thinning, do it in some maybe patchiness, not everything the same. He actually, in his paper, shows that it's actually compatible with the California spotted owl. But there's no doubt that you're going to have some winners and some losers. And probably in my opinion, and also research shows, when we have big fires like the one you alluded to on High 5, that changes habitat so abruptly. Some species actually do better. Some species do better, very open forest species, but it's a very small subset. But I think for the species that we probably are interested in for the long term, getting conditions a little bit more in the historical sense helps them, reduces some abundance, but keeps them on the ground maybe for a longer period because of reduced high severity. So there's a whole research dilemma there or area that could be explored. Gavin Jones is phenomenal. He works in California. Maybe someday you could ask him to come. He works out here all the time. He's actually University of Wisconsin of all things. So, but he actually works out here. So who knows, maybe he could come give you a talk and he could tell you about his research.
Thank you. He also answered, I asked the question that I was thinking about the wildlife. The other thing is, what kind of indigenous people and what states, so that we have something to compare with, and you also give them credit for what you are doing now. So go on.
No, this is really an interesting piece because, indigenous people, as you know, have been treated horrifically in this state. Genocide, forced killing, taken off their land, colonization. I teach a class, we just finished it. It's actually fire and culture in California. And half of it is taught by an anthropology professor. And this is what I alluded to. 5 indigenous scholars come in and they talk about their history that's been passed down through their ages. And some of their history makes you cry. I mean, just literally shocks you to your human core. But I think but they're also very interested in maybe energizing their cultures again. There's a fellow named Ron Good. Ron Good is a chairman of the North Fork Mono, and he actually burns just below Mariposa in the southern Sierra Nevada. Ron is one of the preeminent cultural burners in the state. And it's interesting, I've burned with him several times now. And he always will tell you, like I just showed you, I'm burning to reduce fuel loads. I'm burning maybe to kill some trees to try to reduce forest density. Maybe burning to get some of those shrubs back. So maybe we get some habitat for some of the wildlife we just alluded to. When Ron talks about burning, he says, I'm burning for culture. He says, I'm burning so the young people in my tribe can understand how we connect to land. And we will do things like generate food. We will do things that generate basket materials. We will do things that generate spiritual value, but he burns for culture. And he says it so clearly when we burn with him. And it's a real different way. When we start to burn with Ron, when I do burn, we get into a meeting, we have a safety briefing, we have our Nomex on, hard hats, we're all talking about the weather. When Ron starts, we get in a big circle and he actually gives a smoke blessing to everybody. So we actually in a circle, and if you choose to, you step forward and a tribal member will bless you in a sprig of smoke and say, you are blessed to participate today. So talk about a different way to look at land and how to connect. When I hear indigenous people talking about stewarding land and having that philosophy that is steadfast, I think it's exactly what we have to do. We have to have that commitment to the land, work with the land, steward it, and bring it forward, just like indigenous communities have done for millennia. And we've been trying to do that, but we haven't done it.
We're running out of time, so I think we're going to only get one more question unless you're really fast at answering it.
Yeah, hi. So I'm sort of guesstimating that roughly 20 million acres in the state have been intensely forested over the century or so. And I hear you saying that we're doing restoration, maybe 1 million acres if we're lucky. So you got another 19 million. It seems to me that as a practical matter and as a policy matter, as an economic matter, that what is going to happen, and the question is what should happen. What's going to happen is most of that's going to burn. There's just no way around it because you're not going to get it cleaned up fast enough. So the question policy-wise is, what work is being done currently and what needs to be done to restore those really badly burned forests that you mentioned at the beginning that aren't even regenerating themselves?
No, you've hit it on the head. Yeah, the number like 20, 25 million acres that are out there, just in California. You could talk about Oregon, Montana. We could have conversation, all of them, right? So the numbers are startling. And just like you say, 1 million acres a year, that's the goal by 2025. That's been signed by the Forest Service and Governor Newsom. So 1 million acres a year restoration, 25 million acre backlog. And the other thing that we chatted about, once you get that 1 million acres treated, you got to come back in 10 years and do it again. So you're constantly chasing. So how do you go out to get the next 2 million? You got to go after the next million. So inevitably wildfire is going to be the biggest change of our forests in this state. So probably one thing we might do, and this has got some risk, is not put out right now, California, anywhere in the West, 98 to 99% of all wildfires are put out 100 acres or less in size. Many of those are under moderate conditions, low winds, low temperatures. Maybe there's times when we say, we're going to let that fire do some work under moderate conditions. We're going to let that sucker burn and we're going to monitor it carefully, do the best we can. And we're going to get fire on the ground, not at the worst conditions, which we actually have now. Maybe we put some of that on there. If we don't do something like that, you're absolutely right. Wildfire is going to be the biggest mechanism and hopefully not the most high severity that actually is going to change our land. And it's really, that's startling and actually very difficult to think about.
So we're out of time, but I do want, there's one question in the Zoom audience that I think is important. If you can answer it quickly for us. It says, I live in the foothills with 10 acres. What can my part be in reducing fire risk?
Well, that's a great question. You know, I think there really is all of us. I have a cabin, Mary and I have a cabin we're working on ourselves. Doing, the defensible space that you all know about, trying to reduce your vegetation near your home, reducing your forest density to actually allow if a fire comes at your house, that you can actually get the fire on the ground for suppression resources. And the one thing that's so important, work with your neighbors. Your 1 10-acre place could make a difference. But under the worst conditions, it probably won't. But if you work with maybe half of your neighbors and actually have an area that's a donut, it's pretty big, a few 100 acres, you got yourself a package. And that's probably what's going to take for us to keep our fire insurance. It's probably going to take that neighborhood idea. So I would encourage us to do that and also work with our neighbors.
Great. Thank you so much. Really appreciate your time today.